be sold. Some of the financial. Okay. Let me just verify one second. Okay. A small pond of a depth. Okay, there is a small pond of a depth 0.5 meter is exposed to the cold winter. Okay, with outside temperature is equal to 263 Kelvin, and the thermal conductivity. Okay, K ice is equal to, I know. Okay, K ice is equal to 2.2 watt per meter per Kelvin. So latent heat is equal to 3.4 into 10 to the power 5 kg joules per kg, and density 0.9 into 10 to the kg per meter cube. Okay, and okay, so okay, due to the temperature, I guess this is 0 Kelvin. I mean 263. Okay, that is nothing but okay. This is about minus something. Okay, and the temperature of the pond is 273 Kelvin. Due to the temperature difference, it's gonna cool down. Alright, and it's gonna, okay, let us consider this to be the pond, and let us consider it's gonna be cooled down by a small distance x. Dx, this thickness of this thickness dx part of the pond has been converted to the ice. Has been converted to the ice. Okay, the dx part of the ice has been converted to the ice. Okay, dt into latent heat should be equal to should be equal to the, no, let us consider it freezes by the small, okay, 0.5 meter. Let us consider this to be the small dm, small elemental mass. Okay, and rho is equal to mass by volume, and rho into area into dm is equal to, alright, and this dx is gonna vary till I mean, I guess this should also be x distance. Okay, rho a x x x dx and here dt, and the change in temperature is gonna be, what's the difference in the temperature? 273 minus 273 minus 263 263 0. Okay, 10. It's 10. Alright, rho a into x square by 2 into latent heat is 3.4 into 10 to the power 5 joules per kg, and that should be equal to dt into Ka. A gets cancelled. Ka into Th minus, that is 10 degrees Celsius. 10. Okay, and yeah, we can just integrate this time, and K is 2.2 into 10 is equal to 0.9 into 10 cube, and at, I guess that x square should be 0.5 into 10 to the 25 into 10 to the power minus 2 divided by 2 into 3.4 into 10 to the power 5, and 10 to the power 6 into 25 into 3.4 divided by 2 into 0.9 is equal to 2.2 into 10 into T. YT, YZT, Ka into, okay, the change in temperature, alright, 10 to the power 5, and if I 34 into 9 into 25 is equal to 10 to the power 3 divided, and this 17, this is gonna be 2.2 into T. This answer is gonna be in the decimal though. 17 into 9. Did we include the latent heat? Okay, 10 to the power 8 and 2.2 and okay, this will be the seconds. 25 into 10 cube divided by 22 into 10 to the power minus 1, and 17 into 9 into 25 into 10 to the power 4 divided by 22 is equal to T. I guess, let me, 1 second, let me use the calculator. 17 into 9, 17 into 9, 17 into 9 into the into 25. Into 25 into 17 into 9 into 25 into divided by 2.22. 1 second. 1 second. Okay, divided by 222. Okay, 173 approximately. Let's consider it to be 170 days. 170 days. Okay, 173 point something into 10 to the power 4 divided by 60 into 60 into 24. Okay, this is seconds. This is in the form of seconds. Okay, and yeah, on dividing by 60, on dividing by 60, on dividing by 24, then multiplying by uh, 20 days. Yeah, time is equal to 20 days. It's gonna take 20 days. So option A. So yeah, okay, all right, 20 days. Now moving on to the next question, ninth one. A conducting material of a 0 degree Celsius, and okay, material of a uniform area is placed between the two large chambers which are at a 100 degrees Celsius. The conductivity of the rod, okay, K, it increases with X. It increases where X is the distance, the temperature profile. Okay, they are mentioning that the temperature profile of the rod. Okay, we need to show how the temperature varies. That's the temperature profile. Temperature profile of the rod. Profile of the rod. Profile of the rod. We need to show that how does the temperature of the rod decreases. Does it decreases linearly like that, etc. Okay, of the rod. Now K is directly proportional to X. All right, all right. Now since dt by dx into x, that's a K. For some constant K is equal to a, or some alpha x, for some constant alpha into area will remain constant, is equal to d uh, h by dt, dh by dt. Okay, okay. Now with the change in temperature, since this is the temperature gradient, how is it gonna vary with the how is it gonna vary with dx by x, dt by alpha a, this doesn't matter. Okay, dt alpha dx by x. Now it's gonna if I integrate this, it's gonna be 1 by x. 1 by x is nothing but ln of x, so it's gonna vary with log, log function. How is the log function gonna be? The decreasing logarithm function is gonna be like this. No, it's gonna be like this. Yeah, it's gonna decrease. So the temperature profile, which was like this, it's gonna decrease like this, like an log. It's gonna be maximum and it's gonna decrease. So that corresponds to the option B. Option B in the question. Order. Option B. Ninth one. Option B. Yeah, we are correct. Okay, next question. 10th one. Okay. 10th one. The wall of a house is made of two different materials of the same thickness. The wall of a house. The wall of a house. The wall of a house is made of two different materials, or made of two different materials of the same thickness. Temperature of the T1. the temperature variation the thermal conductivity. Okay, of the same thickness. So it's like this. This part is outer wall, outer wall, outer wall. This is at a temperature T2, and this is the inner wall, inner wall, inner wall. Same thickness, by the way, same thickness T. T. Mid. Okay. And this is at a temperature T2 is greater than T1, so the current is gonna flow like this. Okay, now and given the temperature profile like this is decreasing like this, here it's decreasing like this. So I need to compare the thermal conductivity. Can we compare the thermal conductivity? Here the slope is comparatively greater. I mean there is a slightly, okay, not slightly lesser bending, but here the bending capacity is a greater. That means, I mean, like the temperature is decreasing at a faster rate here. That means here the conductivity is greater than this conductivity. So outer conductivity, the conductivity of the outer wall is less than of the, so therefore the thermal conductivity, I mean to say the thermal conductivity of the inner wall is less than the thermal conductivity of the outer wall. I mean greater than outer wall. I mean, oh, whatever. Option A. 10th one B. Oh, thermal conductivity. Thermal conductivity. Karo. Thermal conductivity of the outer wall. It's gonna be sure. Okay. So a thermal conductivity of the inner wall okay, I'm back. I guess we have to find the temperature here, that is T dash. Okay, since T2 minus T1 is equal to T1 minus T2, T dash, and K dash we need to find A divided by till L thickness, T2 minus T dash minus T2 is equal to Ka divided by length all the way uh, since if you observe the graph, yeah, the decrease is okay, not bad. Yeah, the decrease is decent. So, but here the decrease is larger. So, this is greater than this. So, if this is greater, then k dash should be less. So, k will be greater. Yeah, that's what is happening. So that's why. Yeah, I understood. Oh, shit. Ordered. Rod. 11th one. 11th one. A rod of uniform cross section but non-uniform thermal conductivity which vary as x. A rod of TH, TL, here x is equal to 1 and x is equal to L at this part, and at this part x is equal to L, and okay, and k varies as k naught x square by L square is kept between the TH. Okay, uniform. We need to find dt by dx. Okay, I need to find. I need to plot the graph. I need to plot the graph A, uniform cross section area. Okay, I need to plot the graph of uh, dt by dx, dt by dx against x. All right, all right. So yeah, x square by L square dt by dx and A is equal to dh by dt. I mean, the flow of the current will be constant, like throughout the. So L square by x square A is equal to dt. Okay, this doesn't matter. Is proportional to dt by dx. Now, if it is 1 initially, if it is 1, then it's gonna be L square. It's gonna be L square. So it's gonna be the maximum. Then it's gonna decrease, and at L square, it's gonna become 1. But here it's gonna be maximum. It's gonna be to the maximum. All the way. And and they also mentioned that, so it's lying between 1 and L. If it's lying between N1 and L, so here this is gonna be something lesser than L. I mean, okay, okay, let us consider it to be 2, and 2, 4. It's gonna be like okay, 1 for 1. It's gonna be 4. That's the maximum. After that, it's gonna become. So yeah, it's decreasing. How is it decreasing? It's decreasing linearly. Is it decreasing linearly? I would say it's decreasing. Yeah. So yeah, it's decreasing it's not decreasing linearly, it's decreasing with a degree of 2. 1 by x square dt by dx. So the graph is going to look like this. At 1, it was L, it was at its maximum potential, that was L, the length. Now it's going to decrease. When it's decreasing, as it is decreasing, dt by dx is going to decrease. I mean, not length. Length is obviously by length will remain constant, but I am saying as it moves, the temperature gradient will decrease. How will it decrease? Will it decrease linearly or will it decrease with a degree of 2? It's going to decrease with degree of 2. We proved it. That's what we proved it. So 11th one, option D. Yeah. Uh, Alright, time is up. Uh, I'll take a 10-minute break, and yeah, we'll see you soon. And yeah, option D is correct. That's all. And yeah, I will do circles. I'll do circles, I guess, because I didn't touch circles for a while. Yeah, see you in like 10 minutes. Oh shit. Alright, I'm back. So, yeah, it took a bit while. Yeah. Okay, we will be doing circles. Before circles, I need to revise circles because I forgot so many shading from the circles. Yeah, I need to revise the identities and as well as shit. Yeah, I have written the notes of circles. Let's just revise it. Wait a second. Alright. Yeah, I found it. That brings wide since I touched coordinate geometry. Yeah. Okay. Yeah, so we'll be doing revision from the basics. I mean, like basic identities and shit. Yeah. Alright, let me begin the timer. Alright. Okay. Circles. So, yeah, starting from the basics. Like if we have a circle, like with h comma k center, and definitely its equation will be, this is a very basic thing, y minus k square whole square is equal to r square. That is the radius. Okay. So yeah, this was the basic. Now we'll move a little bit. Okay, yeah, and yeah, we can find the radius is equal to g square plus f square minus c square. Okay, and g will be uh, minus h, and f will be minus k, c constant. Okay. In case of a circle, xy should be equal to 0. In second degree equation of conic section, of conic section, second degree equation of a conic section, and yeah, now and right, if the determinant it represents, alright, next, your image of a circle It is another circle having the same radius as origin in the given circle. Okay. Image. Now, next, this is a J topic. Image of a circle with respect to a line. With respect to a line. With respect to a line. So, this is the circle which has an equation x square plus y square plus 2gx plus 2fy plus c is equal to 0. Yeah. Then, and if this is a line, x is equal to y, I mean some equation x is equal to y mx plus c by y, I mean wait, okay, y is equal to mx plus c. Alright. Now the equation or the image will be the another circle. If this is minus g comma minus f, the image of this this will be x distance, this will also be x distance with respect to this line would be the equation of another circle. That I mean we can find the center of this circle by using the image of a point with respect to the line formula and shift. The radius will remain constant. This is r. This will also be r. Order. Okay. And image of a like yeah. Now, diametrical form of a circle. Diametrical, if this is a circle, if this is x1 comma y1 and this is x2 comma y2, the diametrical form, if this is the radius having a center C, alright, the diametrical form will be x minus x1, y minus y1, wait, x minus x2, my bad, okay, plus y minus y2. See, like if this is the diameter and this is the ends of the diameter, this will be 2r, then its equation can be found like y minus y1, yeah, is equal to 0. So this will be the equation of the circle in the form of a diametrical form. Yeah. Alright. Yeah, next. So now we'll move to the parametric form of circle. Parametric form. So if this is the circle and if we need to find any coordinate, this is 0, 0, and if we want to find any kind of a coordinate, it can be like if we have a point P, x comma y, and if we want to write in terms of r, this will be theta and this will be x cos theta, yeah, x cos theta, I mean r cos theta, and this will be r sin theta. So x coordinate will be, y coordinate will be r sin theta. Alright. coordinates of the center, we can just add like using, I mean, we have studied this in the straight line, yeah, nothing special. If they are given the coordinates and if it's not a origin, yeah, nothing else. Equation of a three non-collinear points of the on the circle. Non-collinear. Okay, always a unique circle obtains. Okay, see whenever, yeah, there's nothing else. Yeah. To find the center, 3 points of a triangle from the center will be equal. Okay, like I mean, like we have two methods. If they are given the 3 points like this, and we can find the, but I know we can just substitute in the second degree of equation, but there is a simple method save our time like this. And if I find the midpoint of, I mean, I need to find the angle bisector, equation of the angle bisector, and here as well equation of angle bisector, and you can just find the point of intersection. That point of intersection will be h comma k. Alright, yeah, that's all. That's it. Concentric circles. Okay, concentric circles is very much a circle enclosed in a circle. Yeah, let me get else. Concentric circle. X-axis, y-axis. Now this will be 0 comma r, like a circle having its center laying on the y-axis and touching the x-axis, then its center would be like this. And if, like, these are the some of the special cases. And if we have a circle that is touching the x-axis, y-axis, and having its center laying on the x-axis, then its coordinate, the center would be like this, and we can find the, yeah, equation of the circle. I mean, this can be useful. Now this is the very important. If a circle is touching the both the axes at a one point, then its center will be r comma r. Yeah, like this is r, this would also be r. That's why. Yeah, no, I mean, like, this would also be r. So that's why it's r comma r. Now, yeah, nothing else. Yeah, this is possible in the four different quadrants. It could also touch like this. It could also touch like this. It could also touch like this. So yeah, depending upon the condition which they mention in the question, we can just solve it. Now, power of a point of a circle. Like if this is the circle and we have a point, if it has to lie inside the circle, what is that? The S1, right? Yeah, S1. S1 means like substituting the point in the equation of the circle and the value which we get. If it's equal to 0, it means it lies on the circle. Okay. If S1 is less than 0, then it lies outside the circle. Consider this H comma k. Okay. It lies, and if S1 is greater than 0, then it's gonna lie. Oh, wait. If S1 is less than 0, then it's gonna lie inside, and if S1 is greater than 0, then it's gonna lie outside. Alright. Now that's what's the power of okay. And if they're asking for the greatest and the least distance of a point p x1 comma y1 point p from a circle. Okay, if this is the circle uh, h comma k, and this is the point p x1 comma y1, the greatest and the least. Okay, if we want the greatest distance can be this much. Like if it's outside, or I mean minimum distance, minimum distance, minimum distance. Yo, wait. This would be the maximum actually. This would be the maximum. Uh, maximum. Minimum would be if it's lying here, and that is nothing but the distance of from the what do I say, from the center. Wait. Like maximum distance from a circle, not a center, from a circle is the distance from PC minus R, PC plus R. Yeah, PC plus R. Like if this is PC plus R, and the maximum is gonna be PC, minimum is gonna be PC minus R. PC minus R. Now line and circle, line and circle, line and circle. Now, okay. So if a line is intersecting, like if it intersects, then if it intersecting at one point, then if this is h comma k, that is the center, then the perpendicular distance should be equal to R. Alright, and if it's lying inside the circle, then the perpendicular distance should be less than, less than R. Like it will intersect at 2 points, and if it's then h comma k. Yeah, we can just substitute, and in this case the discriminant would be equal to 0. I mean, like if it's like using the perpendicular distance formula, we get an expression, and in terms of I guess slope, I guess in the slope or x. So if it is intersecting at one point, its discriminant should be 0, and if it is intersecting at a 2 points, the discriminant should be greater than 0, and if it's not intersecting, then discriminant should be less than 0. Yeah, nothing else. And like, and yeah, there is two possibilities that in the case of a discriminant is greater than 0, equal to 0, there is a two cases. Greater than 0, that it, where it intersects 2 points, there the perpendicular distance should be equal to 0. That's the case of a diameter, when the line is acting as a diameter, passing through the circle as a diameter. Alright. Now the angle between the, this topic is using, we are trying to cover as much as possible. If this is the circle and having a coordinate h comma k, this is the perpendicular distance. If this is theta, it should also be theta, right? This is 90 degree, 90 minus theta. Yeah, exactly, this will be theta. And so if this is, I mean, this is a vertical x-axis, and yeah, this is nothing but the line made by the circle, I mean made by the line with the circle. So cos theta is equal to distance from the line. Cos theta is equal to P by R. What is P? Perpendicular. Okay, this is the radius of the circle, and P here is like, wait. So yeah, I understood it here. Yeah. Okay, this is the line. Y is equal to mx plus c. I mean, I wrote this. I mean, it's not exactly so. This is y is equal to mx plus c. This is the perpendicular distance of the perpendicular distance, and the point of this is the point of intersection of the line with the circle. Or it could be like this also, but here it could be like this also. We'll get the same. Yeah, we'll get the same. You get here theta. Yeah, we'll get the same thing here. So here, as we are speaking, this tangent and this line, the angle which we get is nothing but the angle between the line and the circle. That is nothing but called as angle between the line and the circle. It's not like, it's not this side. Don't get confused. It's like this. It's not like this. No. It's like, I mean, if this is the line and this is the circle. Okay. It's not like this angle. We cannot. We are just drawing the tangent. Like I don't know that much geometry, but yeah, it's like this. This is the tangent at that point of intersection, joining, and that angle between it, angle between the circle and the line. Yeah, now we are moving to the tangents. Yeah, the JEE advanced part of the question, I guess so. Yeah, tangent and normal to a circle. Normal to a circle. Okay, let's start with tangent. If we have a circle and the tangent is represented by t is equal to 0. Yeah, that's nothing but a representation of a tangent axis. And this is nothing but like if you have a point x1 comma y1, and this is the equation of the circle x square plus y square plus 2gx plus 2fy plus 2c plus t is equal to 0. x1 comma x plus y1 plus 2g x plus x1 by 2. Yo, wait, wait. Shit. Oh shit. Alright, I was because I got an important email, so I had to go. Okay, okay, we're back. Okay, so where were we? Okay, tangent form, right? Okay. Now transformation of a general circle to a standard circle. Let if this is x-axis and this is y-axis, and if this is the equation of this is the circle h comma k. Okay, transformation. Okay, to convert. Okay, if this is the if you want to make this as origin and convert it into the standard form, that is like considering the circle as the origin, we need to use the transformation of a circle, that is where big X would be equal to x minus h and capital Y is equal to y minus k, and we can just replace this in the equation. Equation of a circle as a point, equation of a tangent. Yeah, this is the transformation of the circle, and you can just substitute in the equation. Yeah. Slope form, if you know the slope of a tangent to a given circle, two parallel tangent with a slope m, x square plus y square is equal to r square. Slope of a circle, slope of a tangent. Now slope form, if you know the slope of a tangent to a given circle, uh, okay, if this is the circle, and if you know the slope of a tangent to a given circle, that is m, then we can also find the equation of the circle. That would be y is equal to mx plus or minus under root of 1 plus m square. This is formed, this equation of a tangent is calculated, this equation of the tangent is calculated by substituting. If this is x square plus y square is equal to r square, I just put the value of y is equal to mx plus c in this equation, and yeah. I found c value in terms of a plus or minus under root of 1 plus m square, or folder. Yo, 1 second. Yeah, actually, I need to go. Something is wrong, by the way. Some personal issue happened. Wait, I need to go.